24, where we're going to do compositions. What a composition is where we're combining all of the different transformations. So if you look at this one right here, look at what's happening. Look at this arrow. It's clear that it just rotates, right? So it just spins like it's like this. It just spins. Actually, it's starting up, so it spins, right? So for the first transformation, it spins. And then for the next transformation, you can actually consider one of two things. Either you could say it moves down, or what I think we're going to say for this is it reflects over this x-axis. So it flips. So it's like it's here, and it flips. Okay, so what I'm going to do right here is I'm going to look at all the different types of rotations, reflections, and translations, and how we're going to write them. So we did this in the last lesson. But so, for example, if we do a clockwise rotation of 90 degrees around the point 4, 6, you do this. You do capital R, saying that I'm rotating, and we'll do 4, 6, saying that's the center of rotation, and then negative 90 degrees. So when we say negative 90 degrees, that's saying a clockwise rotation of 90 degrees around that point. Now, a reflection, you're going to do lowercase r, and all you need to do is just say what you're reflecting over. What I want you to remember for this, though, is that whenever we're gonna reflect over the x-axis, we have to call it the line y equals 0. So let me kind of summarize all this right here, because this is the main stuff we have to understand once we get this, because we should be somewhat comfortable with rotations, reflections, translations already. So it's just writing them in this form. So if we do a rotation, we'll say r, right? And then, right, so this is rotation. We'll do reflection. We'll do translation. Okay, so when it's a rotation, we do R, and then right here, you'll put the center, and then comma, and then right here, we'll do the degrees of the rotation. So it's R, put the center, comma, the degrees of rotation. For a reflection, we'll do lowercase r. And then right here, we'll just have the line that we are reflecting over. Now, when we do this, I want you to remember that y equals 0 and x equals 0. Remember, to say y equals 0, that would be like this. If I have an xy coordinate, at this point right here, this line going across, right, the x-axis, right here, y equals 0. Okay, think about it. Y is 0. See, if I went like this would be y equals 1. Here would be y equals 2. But right across here is the line y equals 0. And right across here is the line x equals 0. Okay? So y equals 0 is the x-axis. And then x equals 0 is the y-axis. Okay, and then lastly, translation. We're going to do capital T. And then what we put right here is how much we are moving by. So you can either do it like this. I'll give you two different examples. If I say T and I do like AB, that means I'm moving by AB. So if AB is a certain segment, we just move by that direction. Or we could do T and you could put like, 2, 4. That would just be X goes to the right 2, Y goes up 4. So that's how we're going to do these things. So if you look right here, the next thing I have on this, on here is we look at how we would do a reflection. So if we reflect over the line y equals 0, that's the x-axis. So to reflect a reflection across the x-axis, that'll be y equals r, y equals 0. So that's what's happening right here. Look, if you go to y equals 0, which is this right here, this arrow is reflecting over it to land down here. And then lastly, I give you an example. If you need to do a translation, if you're going to go up 1 and to the right 1, we do T1, 1. Now, when you read a composition, you actually will go from, I wrote left to right, but actually it's right to left. This is a typo right here. I'm going to fix it on the spot right here. You go from, so normally when you read things, you read from left to right. So if you look at this right here, okay, let me get out of this view. Let's go right here. Okay, so if you look right here, the notation for composition of transformations is similar to the way you do composition of functions. And what you do, so the one we just did, we would write r, y equals 0, and then r 4, 6, comma, negative 90 degrees. What this would be right here, this is a, if then after that you did a reflection to the x-axis, so a reflection over y equals 0, you wouldn't put it further inside, you would just put it on the left. And then if you have another thing to do, do a new parentheses, put it on the left of that. Do you see this? So if we do all these, and then it says, oh, after you're done, do one more thing. Make a set of parentheses to close in what you've already done, and then put it on the left. Okay, so we don't put it on the right. Instead, what you do is each new thing you do, you put on the left. So that means whatever's deepest inside the parentheses, which will typically be on your farthest to the right, is the first movement you do. Then you do what's next right here. Then you do what's next right here, okay? So that's why I said do what's on the right first, and then do the next things as you move to the left. So for this one, if we imagine A is at 0, 0, B is at 1, 1, and C is at 0, negative 1, let's write the compositions. So first we do a clockwise rotation of 60 degrees about the origin. So as we do these, I'm going to write them right here. So a clockwise rotation of 60 degrees about the origin. So, okay. So clockwise rotation of 60 degrees about the origin. So it's a rotation, so we'll do capital R. And then it's about the origin. Remember, when you're doing an XY, the origin is the point in the middle. So what is the point in the middle? 0, 0. So we're rotating about 0, 0. And it says it's a clockwise rotation of 60 degrees. So that means we need to say that the amount we're rotating by is, remember, clockwise is negative. So it's negative 60 degrees. This is our first transformation we're doing. So all I'm doing right here is I'm just writing out what this describes. And you guys need to be able to do this by the end of this lesson. So make sure you understand what I'm doing. A clockwise rotation of 60 degrees about the origin. So that's why I do R for rotation, origin is 0, 0, and then negative 60 degrees is how you would say clockwise. Followed by, so if it's followed by, I'm doing a new thing now. After I do this first rotation, then we do something else. So the next thing goes on the left of it. You're going to be tempted to write something and then move to the right, but we will write down what we do, and then on the left we do the next thing. A translation by the directed line segment AB. Now that might seem confusing, but so it's just one thing at a time. So let's do followed by a translation. So I write my rotation right here, and then the next thing we have a translation right here. Right, so it goes on the left, and we need to say how much we're translating by. And it says we're doing it by the line segment AB. This is where the factor they give you where A, B, and C are is going to matter. So by the directed line segment of A to B. So let's look right here. A is at 0, 0, B is at 1, 1. So I'll actually go ahead and graph this. So if we started off right here, A, which was at 0, 0, and we go up to B right here, which is at 1, 1. How much did we move by? If you went from 0, 0 up to 1, 1, well, we went over 1 and up 1. So our translation is 1, 1. So this right here says take whatever the object is, and we don't need to draw it yet. Rotate around the point 0, 0, so whatever the object is, rotate clockwise 60 degrees, and then once you're there, you move up 1 over 1. That's what this is all telling us to do. So if we look at our selections, here we have rotate, this time it put O as the origin, which is fine. So you can do that then. You can either put 0, 0 like I did, or if you do O, we'll assume you need origin. So that's something we can do. So rotate around the origin, -60, and then, so move to the left to see what's next. You do translation of 1, 1. 3 translations, each of directed line segment AC. So let's see what AC would be. A is at 1, 1, and then C is at 0, -1. So to do a translation from A to C, we start at 0, 0, and we go to 0, -1. So this one will look like this. We'll do a translation of AC. So we'll do T that goes 0, -1. Again, that's how I would get from A to C. If you need to plot it to see that, you can. But and we're doing it 3 times, it says. So let's do right here, T 0, -1, T 0, -1. So I know I'm getting kind of cramped over here, but you see what I'm doing. You do T 0, -1, T 0, -1, T 0, -1. So just the same translation 3 times in a row. So right here, we see our answer right there. Okay. And now we reflect over the line x equals 2. Oh, no. Reflect over x equals 1, then reflect over x equals 2. Okay, so we reflect over x equals 1, then we reflect over x equals 2. So reflect over x equals 1, then reflect over x equals 2. Reflect over x equals 1, then reflect over x equals 2. There we go. Okay, so now what I want you guys to try to do, you'll have this, and you're going to follow these and decide if it would land on arrow A or B. So I want you to actually try this yourself, do 4 through 7, see what you come up with, and then I will do it. So press pause, try 4 through 7, and then you can press play. All right, so I'm not going to draw this perfectly, but basically we have so we have an arrow. I mean, you can't see what I'm doing really, but I'm going to zoom in a second. And then okay, so once again, I drew it kind of fast. I'm not making it perfect, but you start right here. Here's the point, 4, 0, and you can either turn it into this arrow over here or this arrow over here. And just to keep track, the arrow on the right is A. The one on the left is B. So let's imagine what will happen if first we rotate around the point 40, 90 degrees. So first it's a 90-degree rotation. Now remember, is clockwise negative or positive? Clockwise is negative, counterclockwise is positive. 40 is right here, that's the center. So the first thing we do is we take this, we rotate around positive 90, which puts us right here. So we're at arrow B for now. I'm doing number 4. But that's if all I do is this one rotation right here. If I rotate around 40, I'll be at 90 degrees, which puts me at B. But then we have to reflect over the line x equals 4. Let's think about what that's going to do. So if we reflect over the line x equals 4, that would be right here. That's the line x equals 4. If you reflect over that, boom, you end up here at A. You see that? So you rotate around 40, which is your point right here. Rotate around that positive 90 to go right here. And then reflect over x equals 4 to go right here. Okay? So we get A for that first one. Let's look at the next one. Would we go on to A or B for this? So this time, first we're going to reflect over x equals 4. Then we're going to rotate 90 degrees. So we're going to do exactly what we did, but we do it in opposite order. So here's what's going to happen. Here's the line x equals 4. So let's reflect over this line. But here's the thing. Our arrow's already there. So all it's going to do is it's going to flip over. But if this arrow flips over, is it going to look any different? No. I mean, it's going to do this, right? You can see the difference in my hand because you see the back, now you see the front, okay? But if this, it's just an arrow, so it's the same thing. I mean, it's just doing this. Like I have a water bottle right here, and I just flip it over. It's the same thing. So that's all that's happening right here is we flip this over. Then we need to rotate. So once we flip it over, then we need to rotate around 90 degrees. So now that it's been flipped over, it's been flipped. Now here's 40, and let's rotate positive 90, and we end up right here. So for this one, will be B at arrow B. Okay, number 6. Let's rotate around 40, but we just do one rotation of negative 90. So we're right here, and we just rotate negative 90, which puts us at A. So for number 6, we're at A. And then lastly, number 7, we go 90 degrees. So we just take the same thing, we rotate 90 degrees, and we end up at B. Okay, so now predict the single transformation that would produce the same image as the composition below. So what would happen if instead of doing these one step at a time, we do all of them? So let's move up one, then move to the right one, then move up one and to the right one, okay? So with this, imagine you imagine that you start here, and the first thing says T 10. So that means we move to the right one. And then it says T01. So that means we move up one. And then it says T11. So that means we move over one and up one. If instead of doing all those steps, we just did them at once, we go over 2, up 2 to get straight to there. So it'd be T2, 2 is how we could combine all of those. So you see, that's how we could take all of these motions, make them one single motion, T22. Predict the single transformation, so same thing. So if we rotate 90 and then we rotate another 90, where would we end up? Some of you can probably just do the math in your head real quick. But still, let's see what would happen. So if we have, say, a triangle right here, first we rotate 90, that will put it right here. Then we rotate another 90, that would put it down here. If you ignored the first rotation of 90, what is that in one step? That's a rotation of 180. So we could rotate around the origin 180 and get straight there. And then lastly, we reflect over x equals 0, and we reflect over y equals 0. So for this one, I mean, if I do the same example right here, if I do this, we reflect over x equals 0. That's this right here. It would just flip my triangle, which changes nothing. Then reflect over y equals 0. We'd end up down here. Let me do another. So I'm doing if we reflect over x equals 0, and then we reflect over y equals 0 is what I'm looking at. Let's do one where it's not right on there. So let's do this. If it was right here, and we reflect over x equals 0, that's right here. So x equals 0 is this. So that would move it over to there. So this is what we started with. I'll circle it. And then now we reflect over y equals 0, which would put us right here. So we go from there and we end down there. So let me get rid of the step in the middle. So what is going on here? What could this be if it's like this? Think about it. If it's rotating, think about right here if it's rotating. It's definitely not moving up 2 and over 2. It's definitely not rotating negative 90, but look, is it a rotation of 180? Regardless of where we started. Look at this. If it's going in a circle, rotation of 180 would put it right here. If this is rotating around the origin, rotation of 180 puts it right there. So once again, just like the last one, our answer is a rotation of 180. Okay, so this is how we put all of them together. So make sure that we're comfortable with this. This is a very important skill. This is what puts the whole lesson together.